All right, we're going to go over the assignment that we did on linear transformations and then the weighted averages. So let's remember before we get started that we wanted to know what happens if we change all of the data. So if we added or subtracted, okay, so if we added or subtracted all the data, then that would change where the center is located. The mean or the median would be shifted. But the spread would not change just by adding or subtracting. But if we multiplied, so if we multiplied by something, then the spread changes in addition to the center. So the center, you could see this right here. If we then multiplied it, then that center is moving from here, out to this location. Okay, so the center is changing from here out to here. So center gets affected by multiplication and division as well as add and subtracting. So here we go. That's what's happening on our number 1. We have this transformation of 1.2x plus 10. So that means that the mean will be affected by both the multiplication and the plus 10. Okay, so then we put the mean in there. But the standard deviation is only affected by the multiplication part, only affected by multiplying by 10, or multiplying by 1.2. Do not add 10 to that standard deviation. All right, the next is the weighted average. So here, oh, you know what? Yes, I did have that. So they are equally likely. So he's got all of that. I guess that they were then equally likely. All right, after that, then we have this one here, where here's the transformed score, 3.5 times the raw value plus 6.2. So the question, is asking multiple issues. So we need to remember that measures of center are changed by the adding by 6.2, and the multiplying by 6.2. But the measures of spread, now what are measures of spread? The measures of spread are range. Okay, we hadn't really talked about that, but that is, of course, a measure of spread. The IQR, the middle 50%, and then that standard deviation, average distance from the mean. So the range, standard deviation, and IQR should only be affected by the multiplication. So that's what makes C false. C says that the range is 3.5 times the range of the raw scores plus 6.2. So it's adding, it's saying, hey, we're going to take that whole range, multiply by 3.5, and then shift it 6.2. Well, shifting it 6.2 does not change the spread. It just shifts where it is located, but it doesn't change the spread. All right, so this was also another weighted averaging problem because we had 30% for the labs and assignments, 30% for the labs and assignments for the second semester, and then 40% for the final exam. So we wanted that to total out to be an 80. So we kind of solved it that way. 30% times that, 30% times the second semester plus 40% times some unknown amount is how we get what we want, and then we solved. All right. Now you might have also just kind of guessed and checked by plugging these numbers in for this X value until you find the one that would give you 80. All right, here we go. This also had 50 of the 1,200 kilogram vehicles, 10 of the 300 or 3,000 kilogram trucks, and then that was 60 trucks in total. So we had to combine all of that, get the total sum of the weights, and then divide by 60 cars to get the average mass of the 60 cars. All right. Here we had everything just raising $1,000. So all that is addition of $1,000. Okay, so actually that's backwards for me. So that's adding $1,000. So that does not change the spread. So the average will increase 1,000, the median will increase 1,000, but the $1,000 will not affect the range, the IQR, middle 50%, not changed, and the standard deviation is not changed. The spread is not changed. All right, next. Suppose each nurse receives a 4% raise. That 4% raise is a multiplier. You're really multiplying by 1.04, so you can increase everything by 4%. So if you think about it, if a person made $100,000, they're going to get a much bigger raise than a person who makes $10,000 because $100,000, 4% is going to be $4,000, but a person who makes it $10,000, a 4% is going to be $400. So it will affect the spread because the bigger the salary, the bigger the raise. So it's this multiplication factor. So we now then have different upper and lower values, and then that will affect that IQR and the standard deviation because that's a multiplication of 1.04. Number 8, again, we were looking for a missing value. So 70% times 50,000, 20% times 80,000, and then 10% times some missing number. So you could have guessed and checked until you found the one that will total up to 80,000, or you could have solved this equation like that. All right, and here we go. Now look here. Each score is doubled. That's multiplied by 2. And then after you multiply by 2, you subtract 5. So the subtracting 5 affects the mean, but not affects the spread. So you multiplied by 2, and then you subtracted 5. So subtracting did not affect the spread. It just shifted everything 5 lower for the mean. All right. Now here, let's take a look at what, because I break this question down into a lot of smaller ones. So we have these IQs of 10 randomly chosen 5th grade students. So here's what they are. Now, I guess I could have put that in my calculator to find that 5-number summary. But I went ahead and I did the 5-number summary here. And so I guess I had put all those in there, and that's the 5-number summary. Now, compute the outlier fences with the IQR rule and see if a student that has an IQ of 96 is considered an outlier. So the lower fence is Q1 minus 1.5 times the IQR. So I figured out the IQR. So that's 100. Remember, we have a lower outlier if you have data below the lower fence, data below the lower fence or above the upper fence. So 96 is lower than the lower fence. So 96 is an outlier. All right, now determine the 5-number summary. Is the 5-number summary what? Let's see. Is the 5-number summary this? And so that answer is yes, because I just did the 5-number summary up here. I guess I listed that out twice. And then here we go. If 96 was removed from the data set, is the mean of the 9 scores going to be higher or than the mean of the 10? Let's think about that. If you removed a lower outlier, say you had a 0, and that's a lower outlier, what happens if you remove that 0? What's that going to do to your average? It'll make it go back up. So removing a lower outlier makes the scores go back up because that 96, that lower outlier, is pulling the average down. All right. If the value 96 were removed from the data set, will the standard deviation be lower than the standard deviation of the 10? And yes, because 96 is an outlier. What does an outlier do to that spread? The average distance from the mean is more because of that outlier. So you take that outlier away, and that average distance from the mean is it's not as big. It has gotten smaller. Okay? Now, if the value 96 were removed from the data set, will the IQR of the remaining 9 scores be lower than the IQR of all 10 scores? So I recalculated that because I just thought since they're removing one piece of data, that kind of shifts where the mean and the median and all those kinds of things are. So I went ahead and recalculated. So the idea was that the outlier does not directly affect the IQR. That's what was really the idea of what was supposed to happen. But in this case, they actually like removed the outlier, not just changed it. So it changed the location of where the IQR things are. So I actually did recalculate. So I found where the Q3 is and what the Q1 is and found that yes, Q3 minus Q1 is actually larger. So that was unexpected because I expected it to say that the IQR is not affected by the outlier. But because they took it away, that took a piece of data away, that ended up changing things. All right, so that's all of that. I hope that clears up questions you may have had over the rules of these linear transformations, okay? And then how those weighted averages compute and work.